All right, PreCalculus, here's section 1.5.1, which just means the first day of section 1.5. So if you want to find it in your textbook, go to section 1.5. We've got two more functions to talk about. One you're familiar with from Algebra 2, the other one's going to be new to you. So let's talk about absolute value function. Looking at it, is it symmetric across the y origin or none of the above? Hopefully you're starting to be able to see this anyway. Symmetric across the y. If it's symmetric across the y-axis, is it odd, even, or none of the above? It's an even function. Yay! All right, what is our domain for this one? From negative infinity to positive infinity, right? Keeps going on and on forever in both directions. What about our range, though? It comes down here to 0 and then back up. So my lowest y value is at 0, including 0, all the way to infinity. Oh, I forgot to mention up here, no x or y intercept because of those asymptotes, right? What about for this guy? Do I have an x-intercept or a y-intercept? Yes, we do. Right there at that point, 0, 0. Any discontinuities? No jumps, no asymptotes, so it's continuous on the entire domain, which would be 0, 0, because I should say continuous on, sorry, not 0, 0, negative infinity to positive infinity. We can do our limits as we go to negative infinity. This graph is going off to positive infinity. My limit as x goes to positive infinity. As x goes to positive infinity, y's are going to positive infinity. Decreasing and increasing. So as I go from left to right, this graph is going up or down between negative infinity to 0. It's decreasing between negative infinity to 0. And going from 0 to infinity, my graph is increasing. All right. I feel like I'm missing, maximum minimums. We don't have an absolute maximum, but we do have an absolute minimum, right? And where is that at? 0, 0. So that's it for absolute value. Here comes the new one that we haven't seen before. It's called the step function. You could also see it called greatest integer function. All right, and this one you really can't see because it's fuzzy, but f of x is equal to this thing that looks like this. It's kind of like a bold-faced bracket on either side. And so that's the greatest integer function. And the greatest integer function, I should probably write a definition just so that we've got it nice and clear. Let me pull it up real fast. Greatest integer function is defined as the greatest integer less than or equal to x. So before we get into graphing it, let's see if we can find some greatest integers. So what if I said the greatest integer of 3.5? So I want, what is the biggest integer that is less than or equal to 3.5? So the biggest integer that is less than, we can't say 3.5, right? Because 3.5 is not an integer. It's got to be like a whole number, either a positive or negative whole number. What is the biggest integer that is less than 3.5? That would be 3. What would be the greatest integer of 0.25? What's the biggest integer less than a quarter? That would be 0. What is the biggest integer? It's going to catch up eventually. 1.37, why not? This is where it gets tricky. What's the biggest integer less than negative 1.37, that would be negative 1. Mind blown, right? But think about it, when you're over here, if I am at negative 1.37, the integer, oh, I said that backwards, didn't I? Sorry. Not negative 1, negative 2. I'm glad I have the graph right there. The integer that's less than, that's why it's confusing, integer that's less than 1.37 is actually negative 2. The one that comes right before negative 1 would be negative 2. What comes right before 3.5? 3. What comes right before 0.25? 0. These are kind of easy. You just kind of chop off the fraction part, right? You can't do that over here because you make the same mistake that I just did. What is the integer that comes right before negative 1.37? Negative 1.37 is out here somewhere. So what comes right before that? Negative 2. So my value is negative 2. Let's practice another one since I botched that a little. What about negative 5.76? I said 5 and wrote 4. What about negative 4.76? What comes to the left of negative 4.76? That would be negative 5. So then we get this really interesting looking graph. So anything between 0 and 1 is going to be right here. But when I turn to 1, 1 is less than or equal to 1, so it jumps up to 1. So between 0 and 1, any value between 0 and 1 is going to be here at 0. Any value between 1 up to, but not including 2, is going to be at 1. Any value at 2 up to, but not including 3, is going to be here at 2, and so on and so forth. And because it makes these little stair steps, it's called the step function, is its common name, but it's also called the greatest integer function. This part isn't the hard part. The hard part is when we actually start trying to transform the sky. So let's see if we can come up with some attributes real quick here. What would be the domain of the sky? This is challenging, right? The domain, like from here to here, would be, say, what is that? 1, 2, 3, 4. Negative 4 to 3. Negative 3, but not including 3. Union, negative 3 up to 2, but not including negative 2. Sorry. Union, negative 2 all the way up to negative 1, not including negative 1. What's going to happen to these guys? Is negative 3 in this one? No. But is it in this one? Yes. So remember how we talked about this before? We can collapse that down, and that is really just from negative 4 to 2. But 2 is included in this one, so I could just flap this piece down, right? So really, it's going to go from negative infinity all the way out to infinity, and it's included everywhere. It's so hard to see on this graph. Because I keep thinking there's a hole, there's a hole, there's a hole, but each time there's a hole, what happens? It's filled up by the next piece of the graph. All right, let's look at the range. Okay, if we just look at the range of what we see on the board right now, I've got a y value of, what is that, 1, 2, 3, 4, negative 4. I've got a y value of negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. This is going to keep going and going. This is going to keep going and going. What set of numbers is that? Integers, right? Because we've got negative whole numbers, positive whole numbers, including 0. So the range is going to be the set of all y's, such that y is an integer. See how it's coming back? Thought you could get rid of that set notation. Not so easy. There we go. There's our range. It's just the set of all our integer numbers. All right, domain, range. Do we have a y-intercept? Yes, we have one y-intercept. It's right there at 0, 0. Right, because we're not open here means we're not including it, but we are including it there. What about x-intercepts? Notice how I say intercepts. It's going to be every single point between 0, 0, all the way up to, but not including 1, 0. So there's one at 0, 0, there's one at 0.10, there's one at 0.110. How many x-intercepts are there? An infinite amount. Do I expect you to come up with every single one of them? No. So you could say an infinite amount between x equals 0, or maybe you say an infinite amount on the interval. How about that? 0, 1. Including 0, but not including 1. All right, that's domain and range. Do we have an end behavior for this? Not really. I'm not going to ask you to find end behavior. You kind of do in some sense, but we're not going to go there. That's a little too technical. This guy isn't really even increasing. Is it continuous? Nope. We have jump discontinuities, right? Where do those occur at? At every, what? Integer, right? At every integer, it jumps up to a new value. I think that's about as much as I really want to do with a step function. I'm not going to ask you to analyze it quite like all the other ones. You will get questions where I'm asking you, well, if this is the number, what is the greatest integer of this number? So you will need to be able to come up with these guys. I might ask you about the domain, the range, and I might ask you about where do those jump discontinuities exist, but that would be about it for the step function. We're going to play around with it a little bit. You need to be aware of it for maybe a PSAT, SAT. Probably not, but maybe you'll see it on there. And then a little bit in calculus.